Hello children, I'm sorry I couldn't be with you today. I want you to take a few minutes and complete this warm-up, so I need you to pause the video and actually complete the warm-up on your warm-up paper. And then when you are ready, you may press play again. Okay, you should have completed the warm-up and now you are playing again. And so let's look at the actual answers here to make sure you understand what you are doing. So check over your work. First of all, whenever we're dividing, remember that means that we are actually subtracting exponents that have the same base. And it also means that you're actually dividing the coefficients. So 15 divided by 5 is 3. And then take your m and you subtract the exponents. Now remember, if you will put your variable wherever your highest exponent is, then it will remain positive. So if you will do 7 minus 3 and then keep it in the denominator, then you will have m to the 4th power. Okay, because notice your directions say only positive exponents. If I go to number 2, I have power to a power, so I'm distributing here. So that would be x to the 1st power, and 1 times 4 is 4. And then y, 5 times 4 is 20. And then leave your denominator the same, 2yx squared. And now I've actually got to simplify this new fraction that I have. So 1 over 2 will stay the same. Put your x. 4 minus 2 is 2. Keep it in the numerator because 4 is bigger. And then y, 20 minus 1 is 19. Keep it in the numerator because 20 is larger than 1. And so then I have x squared, y to the 19th power divided by 2. Number 3, multiply your numerator. 4 times negative 2 is negative 8. Put your a, b cubed, because you can't actually add those exponents. They're different variables. Now on the denominator, you got to distribute the 2. So that would be 2. And then 1 there's an exponent of 1 times 2 is 2. So 2 squared, which is 4. And then a, 1 times 2 is 2. And then b, 4 times 2 is 8. Now I can actually divide negative 8 by 4 to get negative 2. It will go in the numerator because it is a whole number. And then I have the higher exponent in the denominator, so keep a in the denominator and do 2 minus 1, which is 1. And you don't have to put a 1, remember it's automatically understood. And then put your b, 8 minus 3 is 5. Central question, if the term squared means I multiply a number by itself 2 times, then what does the term square root mean? Okay, so 4 squared means 4 times 4. 5 squared means 5 times 5. We talked about these yesterday whenever you were given a task with a few days ago. But anyways, square root is something else. For example, if I'm taking whenever we did exponents, if we take the square root of 25, what number times itself is 25? 5 times 5 is 25. So square root means you have a number 2 times that's itself. So for example, 3. 3 times 3 would be 9. So the square root of 9 is 3. 10. 10 times 10 is 100. So the square root of 100 is 10. So it's a number that you multiply by itself. And then you can take the square root of that number. So we're going to look at that today. Your standard is changed. You're looking at EE2. Use square root and cube root symbols. You're not doing cube root yet. You're just looking at square root. And we're actually going to go perfect squares from 1 to 25. So you're actually going to square those today. Remember what an exponent is. It's the number that actually tells you how many times to multiply the base. Square root is what you're looking at today. One of two equal factors. So if I have 25, the square root is 5 because 5 times 5 is 25. Radical symbols, what we use to show that we're taking the square root. And of course, I want you to copy all these into your notes. So if you need to pause, go back to the previous slide and pause if you need to. Perfect squares, a number that has a rational number as its square root. Okay, rational number here is meaning a whole number. We'll talk more about rational numbers, irrational numbers a little later in this unit. We're just not there yet. So if you need to stop the video for a minute and copy these down, including these, please do so. Okay, what is the area of this square? So notice I have 2 on this side, I have 2 on this side. Remember the area is length times width. So if I do 2 times 2, it is 4. Or you can say 1, 2, 3, 4. So 2 times 2, 4. Perfect. What is the area of this square? Well, I have 1, 2, 3, 4, 5 across the top. 1, 2, 3, 4, 5 across the side. So 5 times 5 is 25. Or if you add all squares, you're going to get 25. Okay, this would be a 3 by 3, so it is 9. Very good. Area of this square would be a 4 by 4, so it is 16. Good. Okay, What you're going to do now is you're going to pause this video and you're going to make a list of 1 through 25 on your paper. So I want them to be, like, for example, you have blue lines that go left and right, and you have a red line on the left-hand side of your paper. So beside that red line, I want you to number 1 through 25 all the way down. Do not skip lines. Okay? Once you make that list of 1 through 25, I want you to take each number and square it. So beside the 1, you could write 1 times 1 and then put equals 1. Beside the 2, put 2 times 2 equals 4. Beside the 3, put 3 times 3 equals 9. You're multiplying the number by itself all the way through 25 till you have a list of perfect squares. Pause this video and do that now. Okay, now let's check your numbers and make sure they are correct. So on this slide we have 1 through 16. So beside the 1 you should have 1, beside the 2 you should have 4, 3 you should have 9, all the way up through 16. Of course, you could have used your calculator for this, would have been fine. If you need to pause and check, that's fine. Let's go to 17 through 25. Make sure that you have the correct numbers. Okay, so these larger numbers like 289, 324, 361, 400, these are your perfect squares. So if I take the square root of 441, the answer is 21, because 21 times 21 is 441. So this shows you how to take the square root. So you have a list that you can actually use 2 different ways. Okay, so if I say, what's the square root of 169 children, you would say 13. If I say, what is the square root of 400 children, you would say 20. If I say, what is the square root of 64, you would say 8. Okay, and then of course this list always, it goes up through 25. Now you can keep going a lot further than that, but your standard only requires you to learn 1 through 25. How do I know when my answer is negative? So a negative sign in front of the radical tells me if they want the negative answer. So if they just say, what's the square root of 9? Then they want to know 3. If they say negative square root of 9, they want to know negative 3. Square root. If I ask you to take the square root of 36, you would tell me 6. If I ask you to take the square root of 100, you would tell me 10. If I say, what is the negative square root of 16, you would say negative 4. Very good. Always checking your list until you have them memorized. Okay? This is where we're going with this when I come back tomorrow. We're actually going to work with equations and say, okay, well, if it says square root of what number equals 6, what number does x equal? The square root of what number equals 13? So what does m equal? Okay. Are you going to get a task now that actually goes through and reviews with you the perfect squares? And it also talks about area and perimeter. So let's talk about that for just a minute. What is area? Area is whenever you take the length times the width if you're looking at a square. Okay. Perimeter. Perimeter, remember, is outside of the square or of the rectangle or of the triangle, whatever figure it is. And remember that you add all of those sides. You do not multiply with perimeter, you add. So if you have a square and you have 4 sides, you're going to add all 4 sides. And of course, if it's a square, all the sides are the, yes, same measurement. Okay? So make sure that you pay close attention to that. All right, at the very end, once you finish your task for today, after you collect that from Miss Moat or on the back table, or which way she does that for you, I want you to complete these review problems with exponents. We are going to go over these as the warm-up on Thursday. So please make sure you write down the problem and you write down the answer. Okay, if you want to put it underneath your warm-up for tomorrow, that's fine. But we are going to discuss these and make sure we understand good review of exponents, because don't forget, what do you have on Friday? Yes, you have a mini exam. So if you finish your task early today, please pull out that little half sheet of study guide that I gave you on Monday, and please go back through and review all of your exponential rules. Please take time to make sure you finish your homework. Take time to study. Since you have a laptop, if you want to go into IXL, I'm also listing on the back sheet, in the back of the room where it has your IXL practice, I'm going to list what we've done in Unit 2 as well. So you can go back and review any of those topics. Very important that you study. Okay, we want a good test grade to go on this last test that you're going to have for the first 9 weeks. Okay, and then of course you're going to see the same stuff when we do the big Unit 2 test, which will be in about 3 more weeks, probably 2 or 3 more weeks. I just wanted to get you another test grade in for the end of the 9 weeks. Okay. If you have any questions, write them down so that way you can ask me tomorrow in class, because Miss Moat may not know the answer. She doesn't teach this every day, and that's okay. But please be respectful. I expect absolute best behavior, of course, and I look forward to seeing you guys tomorrow. Thanks.